Hello, and welcome to a little extra video on complex fractions. We're going to start with a basic one where there's no letters, just all numbers. And because there are two fractions on the top and two fractions on the bottom, we are going to multiply through by the least common denominator. It could be any denominator that all of the denominators individually can divide into, a multiple of them, or it could be the smallest one. That's what's the least common denominator. I'm going to look here and say 3 and 4. I know that 12 is a multiple of both 3 and 4, but it's not a multiple of 8. It is a multiple of 2. So I have to find a multiple that is a multiple of each of these. It looks like 24 is a multiple of all four denominators. So I'm going to use 24. So I'm going to multiply each of these fractions by 24. In hopes to eliminate the four fractions themselves. So 3 can go into 24 8 times. So we have 8 times 1 is 8. And 4 can go into 24 6 times. So we have 6 left. So 1 times 6 is 6. And that simplifies to 8 minus 6 is 2. Then below we have 2 goes into 24 12 times. So we have 12 times 1. And then 8 goes into 24 3 times. So we have 1 times 3. So plus 3. 12 plus 3 is 15. And this simplifies to 2 over 15. Okay, let's do one that's a little bit bigger with letters. So once again, we're going to treat this whole number as a 1 over 1. And we are going to multiply through by expressions so that we can cancel out each of these denominators of 1, x and x squared. Well, x squared has the factors x times x. And so we have to use x, and we have to use it the most number of times it's used individually. So it's used twice here in this third fraction's denominator. So we're going to use it twice. And this is an exponent of 2. So I'm going to multiply each term. There's 3 terms, 1, 2, 3. Terms are separated by addition or subtraction. So we have 1 term, 2 terms, 3 terms. I'm going to multiply them each by x squared. So since this is just a 1, x squared times 1 is just x squared. And then x and x squared, this x cancels, and we have just an x left here. So we have 2x. And then both x squareds cancel. And we have plus 3. So essentially, they cancel, but because we're adding fractions, it's a common denominator of that LCD x squared. So they're all technically over x squared. So we can see if we could factor x squared plus 2x plus 3, but it doesn't matter because because it's 3 terms, the only possibility would be 2 binomials, and that would never cancel with this single binomial of x squared. So we're completely finished here. Let's do another complex fraction. So again, we're looking for LCD that we can multiply through and eliminate the fractions by eliminating the denominator. So x plus y and x plus y are both denominators in these two places. And then x minus y is used here. So we have to use each of those binomials. So x plus y times x minus y. So I'm going to multiply by x plus y times x minus y. x plus y times x minus y, x plus y times x minus y, and x plus y times x minus y. So what that does is it cancels out the denominator there. So we are left with an x minus y. And I'm going to keep them in parentheses for now. And then subtracting. And then my top right fraction, the x minus y's cancel. And I have 2 times x plus y. So I'm just going to write it as 2 times x plus y. And then in the bottom left, my x minus y's cancel. And I have 3 times x plus y. So I'm just going to write that for now. Plus in the bottom right fraction, the x plus y is canceled. So we're left with 4 times x minus y. So we have to distribute and then combine like terms in the numerator and denominator before we can try to do any other simplifying. So we have x minus y. We're going to distribute this -2 to the x plus y. So we have -2x minus 2y. And then in the bottom, we're going to distribute the 3. So we have 3x plus 3y. And plus, we're going to distribute the 4. So we have 4x minus 4y. Now we can combine like terms. We have x minus 2x is a -x. A minus y and minus 2y is a -3y. And then on bottom, we have 3x and 4x is 7x. And 3y minus 4y is a minus y. And that is what we have left. So the key is finding the least common denominator that you can multiply through to eliminate the fractions. Touch me back for another lesson.